Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel. Today we're going to continue the series on power rule, and we're going to be working on episode 2 of the power rule series. So in this video, we're going to be working on the second question in this series, which is 8.4 p minus 1.6. So what this question is saying, like, how do you solve this function? Now, if you watched episode 1 of this series, please, if you haven't watched it, I would advise that you go ahead and you watch the episode 1 of the power rule series, because the way I structured the introduction on all the introductory series in all my videos, you're going to realize that I go in detail. So in episode 1, which is the introduction to power series for this basically series, I went in detail to explain a whole lot of things little by little, bit by bit. And I'm going to do the same thing for further episodes, but I'm going to be a little bit faster and less detailed. But I would advise you to still watch the first video. But if you think you have a good grasp and you just want a refresher, then you can go on watching this video. So now the function you're given is 8.4 p minus 1.6 equals y of p. Now the first thing I would like you to know is that the main variable we're working here is the variable p, right? So remember how many times in calculus, the main variable that we work with is x, and we have y of x or f of x. In this particular case, since the variable that we're working with is p, so we're going to differentiate the function with respect to p. So now we're asked to differentiate, right? We're asked to differentiate this function. So it's the same thing as saying ddp of y of p equals 8.4 p minus 1.6. So the goal is to differentiate this entire function, 8.4 p minus 1.6, with respect to p. That's what we're supposed to do. Now, before we start, let me go back to the introductory information. The first thing you have to know whenever you're working with the power rule is that if you're given a power rule, these are the main rules you need to work on whenever you have to differentiate polynomial functions or functions where you're going to be required to use the power rule. Please note this major rules. So the power rule, first of all, is x raised to the power of n. But when you differentiate it, we differentiate now here with respect to x, right? Where the answer is going to be, the n is going to come down. Okay, n is going to come down and become the coefficient of x, and then the power n, which is the exponent, the power n here is going to be decreased by 1. So it will end up becoming n minus 1. So anytime you differentiate, this is what you get. You get the power coming down and becoming the coefficient of what you're differentiating, and then that same power will be decreased by 1. So that is it. Now, since we're dealing with p here, our work, which I'm going to be putting in blue, is going to be the same thing. The same law is going to be d of dp, p raised to power of n, and you have n coming down and p, and then n decreased by a factor of 1. So n minus 1. So this one right here is the differentiated value. At least this is what the general statement looks like. But now that we've had this, one thing you need to know is n has to be a non-zero integer. So what that means is the n cannot be, n has to be a non-zero real number. So that's the same thing. It's not integer, non-zero real number. So that means n cannot equal 0, and n cannot be an imaginary number. So n cannot be an imaginary number. Imaginary number, which means like n cannot be I or j, or basically n cannot be a square root or a cubed root or anything of a negative number. So this cannot happen. So that's what it is. So n has to be a non-zero real number. So that's the first rule. Then the second rule is, let me use red. The second rule is basically the fact that is the sum difference rule, where you have f of x plus or minus g of x, right? This is what it is. Now imagine we're differentiating it, right? So let me remove this here. That would be 2 here. So that would be d of dx. So we're differentiating with respect to x and we will get something. Well, guess what we're going to do? Since we're dealing with p here, I'm going to do the p instead. So that will be just be d of dp f of p plus or minus g of p. And this is really literally going to be the function. This is now going to be equals to just doing d, the function, d of the p, d of the f of p, so d of the function, so differentiation of the first function with respect to p plus or minus the differentiation of the second function with respect to p. And one thing you need to know is it doesn't always have to be two functions, f or g. It could be f, g, h, i, j, k, l. It could be a whole bunch, but because of math and we're trying to shorten the formula, we're just going to stick to two functions. But the truth is, whenever you're given a polynomial function to differentiate, you can end up having 5, 6 terms within the polynomial function. So you can have like a whole bunch of terms as you go along. So you can have 5x cubed plus 4x squared plus 3x minus 5. So that's it. Or you could have 9x to the 8th plus 7x to the 7 plus 6x to the 6th plus 19x to the 5th. You can do that down. So you can have questions like that. So don't expect that every single time you're going to get it to be 2. We just use 2 to kind of do a general formula. So in this case, f of p plus or minus f of g. And this plus or minus is not saying that you're going to have two different values where you do f of p added up. Sorry, f of p plus g of p, you add them up. Or f of p minus g of... No. What you're trying to say is it could be plus or could be minus that can separate two terms. In this particular question right here, that we're given, which is 8.4p minus 1.6, right? This basically here is a negative sign, so we're just going to put a negative in front. It could have been a positive sign. So that's the third, that's the second one. And the third information is just basically having k f of x, right? And we do the differentiation d of dx, right? In this case we have p, so we can just do d of dp k f of p, right? It's the same thing as bringing out k. What is k here? K is just a constant. Anything that is a constant is k. We just do that, then that would k, the constant, multiplied by differentiation of the function f of p. So f of p. So this is like the general information, just so we can use to solve this question. What we just did here is just basically whenever you're given a constant, and that constant, in order for you to differentiate it, you can just bring out the constant and just differentiate the function. Then whenever you've gotten the differentiated value of the function, you can just multiply that answer that you get. So the differentiated value of the function, and you can multiply simply with k or with the constant. So if we're given like 2x cubed, we can bring out 2 and do the differentiation of x cubed, which is 3x squared. Then we multiply 3x squared by 2. So that would be 6x squared. So that is what I'm trying to say. But don't worry, when we start doing problems, you're going to be able to see what's going on. So now we are given this gorgeous question, which is y of p equals 8.4 p minus 1.6, right? So the first thing you have to do is to arrange it to be differentiated. So y of p equals 8.4 p minus 1.6. So that's what this is. So the first thing you have to do is, okay, we're going to first of all have d of the p of y of p equals d of the p of 8.4 p, right, minus d of the p of 1.6. So now that you have this, if you go back, remember what I did here. Whenever we're told to differentiate something that has a plus or a minus, see, this is basically what we have right here. You can see the first thing we did is we can separate it to look like this plus this. That's what we did right here. So that's it. And then you have d of dp, y of p. Then the next thing you have to do is to do the differentiation. So what do? First of all, do the regular thing I talked about, which is bring out the constant. The constant here is 8.4. Bring that out. Then you do a multiply, which we use in calculus. We use a dot in place of a multiplication, because we use x a lot of the time. Many professors would prefer to use dot to show you that you're multiplying something in calculus, because if you use an x sign, because x can be mistaken that as the variable, so you do not know the difference between x as the multiplication sign or the variable, so we just use a dot. So here, just like I did, k dot, it's trying to tell you that this here is trying to say multiply. Okay, multiply. And I think if you're doing calculus for a while or pre-calc, you're gonna be able to you're gonna see some professors doing that. So multiply by d of the p of p, and then anytime you differentiate a constant, that is always going to give you 0. So if we differentiate 17, right? If we differentiate 17 with respect to say x, it's going to give you 0. If you differentiate pi, which is approximately 3.14, it's going to give you 0. If we differentiate a billion, you're going to get 0. So that's the same mentality that we have here. And 1.6 is a constant because it has no variable. So therefore, if it's a constant, obviously with no variable, then it is simply going to be 0. So here I will just have minus 0. And then now, so d of the p of y of p, 8.4 multiplied by d of the p. So differentiating p with respect to p, right? Differentiating the function, which is p with respect to p. When you differentiate a constant, when you differentiate a variable that its highest power is 1, you're just going to get 1. Sorry. So it's basically what I'm saying here is anytime you see a variable like x, like s, like m sitting by itself and it's not x squared or s cubed or m to the 4th, that means you're going to assume, or that means basically that the power of such variables are by themselves with no power written on top. That means that power of that variable is 1. So here we're going to put a 1 here for those people who are still learning. So this is 1 right here. And how do you differentiate that? Remember the power rule. We're going to drop down the power and decrease that power by 1. So this will become multiplied by 1 times p. So then you have that 1 here, 1 minus 1, and that is going to give you 0. So your answer ends up being 8.4 multiplied by 1 times 1 minus 1 is 0. P of 0, anything that is a variable or a constant raised to the power of 0 is always going to give you 1. So that's the same thing as 1 times 1. And 8.4 times 1 is the same thing as 8.4. So this is your answer. So this entire function that you just differentiated right here, right? When you differentiate this function, you're going to simply get 8.4. And that's the answer to this question. Thank you so much for watching the video thus far. May Allah subhanahu wa ta'ala reward you guys and make it easy for you to be able to do your assignments and exams. I like to go in detail. I know this question is pretty easy, and I know some of you already know how to do it so quickly, but it's also good to be able to know the step-by-step process in how you work things out. So here especially is the same thing as saying 1 times P of 0, and that's going to basically give you 1, because anything a variable or a constant raised to the power of 0 is always going to give you 1. So that is just one thing you need to know. May Allah subhanahu wa ta'ala make it easy for you guys that are my students here and your classmates as well. Please keep watching the videos in the series. The videos are supposed to help you guys as best I can. If you have any questions, please send me a question in the comment section. I'm going to try my possible best to answer you. May Allah subhanahu wa ta'ala put barakah in your hard work, and may Allah subhanahu wa ta'ala strengthen you through the whole process and make you among those that would succeed. Amin, 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 ya Rab. Please follow my Instagram. It's just basically Muslima, MUSLIMAH_tutoress, TUTORESS. Muslima Tutoress. Make sure you follow me on there. I have quizzes that I send 3 times a week. And please put more suggestions in the comment section and subscribe so that I can know which other videos in STEM related courses that will be good and helpful to you guys. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.